Hello, thank you, Brendan. I'm so excited for what to come. And hello, everyone. My name is Itai Malka. I was born in south of Israel. I love sea, music, and especially food. And I'm a cloud solution architect at 2B Cloud. So, who we are? 2B Cloud is a Microsoft leading partner. We work with tech companies and providing 24/7 support, expert consultation, and cost optimization. And what are we going to do today in the next 15 minutes? So we are going to see AKS in action. First of all, we're going to make a resources brief. I just created before the AKS, the Application Gateway and Azure Service. Then we're going to talk about the Application Gateway Ingress Controller, which control all the traffic to the cluster. Next, we're going to talk about our use case with two applications. The first one is the sender application, which called the master, and the second one is the service bus receiver application, which called the worker and installed on the Azure Container Instance. The first application, the sender, is installed and deployed to the virtual machine scaleset node and node to the ACI, to the container instance. And the sender application supposed to send the messages to a service bus queue, and the receiver supposed to handle and listen to those messages. And the last one is a KEDA autoscaler. KEDA is a Kubernetes-based event autoscaler that, according to a certain metric, KEDA knows how to apply the autoscaler on a specific deployment inside the cluster. Okay, so I want to start with a mini architecture in a high level. As you can see here, we are using AKS cluster with two nodes inside. The first one is the virtual machine scale set, and the second one is the Azure Container Instance. We have two applications, two pods. The first one is the sender application, App Master, which deployed to the virtual. And the second application is the receiver, service bus app, which deployed to the Azure Container Instance. In addition, as you can see here, we have a HPA, horizontal pod autoscaler. We use KEDA HPA, which is going to listen to the service bus queue messages and perform and apply the autoscaling on the cluster on the receiver application deployment. And the last resource is the Application Gateway, which control all the traffic to our cluster. Okay, so now I want to show you my Azure environment I prepared before. This is the demo AKSRG, my resource group, and inside it you can see all the resources. The first one is the managed identity, which allows the communication between the pods inside the cluster and the cloud services. Next, we have the Application Gateway, which used as the Ingress Controller, AGIC. Demo AKS Cluster 1, this is the AKS cluster. Key vault to store secrets inside it, and a virtual network with 3 subnets in this VNet. The first one is for the AKS pods, the second one is for the ACI, the Azure Container Instance, and the last one is for the Application Gateway. The last resource inside this resource group is the service bus and demo AKS SB. And if I click on it, we can see the queue I already created, named demo queue. And if I go inside the queue, Service Bus Explorer, pick and refresh, we can see that the queue is currently empty. 0 active messages, dead lettered messages, and scheduled messages. Okay, so now I want to show you how I created all these resources by using Terraform. Why using Terraform? Because it's so simple and it's so easy to create a lot of resources. In this case, all these resources I created less than 10 minutes. And that's it. Okay, so let's go to the terminal and let's see it. First of all, I want you to see the ingress controller, kubectl get ingress. We have an ingress named demo ingress, sorry, demo ingress, which exposed to the internet on port 80 HTTP with the host www.demo-aks.com with the this public IP address. Next, I want you to see kubectl get pods, all these pods inside the cluster. As we can see here, this is one replica of our sender application, which going to send messages to the service bus queue. And we cannot find here the second application, the receiver, because there are 0 replicas of this. The service bus queue is empty and there are no currently pods to handle and listen to the messages inside this queue. And that's what we're going to test in this few minutes. Okay. kubectl, let's see our deployment. Okay, and as we can see here, we have the app master deployment. This is our sender application, and the second application, service bus app, with 0 replicas, as we just said now. Let's see our HPA, kubectl get HPA. This is the horizontal pod autoscaler. We used KEDA HPA. And as you can see here, we have HPA named KEDA HPA Service Bus App Scaler and point to the Service Bus App deployment. This is the second application, the receiver actually, and by metric, we're going to increase the number of pods or replicas of this deployment, the Service Bus application. And now I want you to see the deployment of the HPA. Okay, and this is the HPA. And as you can see here, we have the trigger to this HPA is the Azure Service Bus. And the trigger is Azure Service Bus with this queue, demo queue we worked with. And this is parameter message count. This is the metric. So only when the number of messages in the queue is above 20, above the message count, the HPA will update the replica number and another pod will be created inside the cluster. And that's it. The maximum number of replicas, the number of pods that this HPA can create is 10. This is the limitation, max replica count. So even if we need more than 10 replicas, this HPA could not do this. Okay. So now let's test our application, the sender. So let's make sure the queue is empty. Go back to the Service Bus Explorer, pick and refresh. We can see 0 active and dead letter and scheduled messages. Now we go back and we want to send messages to a queue using my sender application. So I just use the post request with a data to send to the server. Okay, so this is a post request to the demo aks.com host, which defined the ingress controller. -d, this is the data that will send to the server, and this message AKS in action will going to send to the demo queue 400 times. And we are expecting to see the number of replicas of the receiving application grow up and increase one by one, because as we just saw 2 minutes ago, the metric in the HPA is the message count and is initiated to 20. So now we send 400 messages to the queue. Now I click enter and post received. If I go back to the queue, click on refresh. Just a moment, sorry. Okay, and now we can see 400 messages, active messages in our queue. So we are expecting to see the increasing in the pods number in our cluster. So let's get to kubectl, get HPA. Let's see the HPA status. Okay, and currently we have 50 messages in the queue from 20. This is the metrica. And as we can see here, there are actually 8 replicas and 8 pods in running status that handle and listen to all the service bus queue messages. And if you're going to see the kubectl, to see the pod status, kubectl get pods -a, we can see that here all the replicas are in creating status and handle the messages and listen to the messages in the queue. And the last thing, if we -o wide, we can see the node of each replica of each node inside the cluster. As I said in the beginning of the session of this demo, the app master is deployed to the VMSS node, and the service bus app, the second application, the receiver, deployed on the virtual node ACI. Virtual node is the Azure Container Instance that used as the virtual node inside this cluster. That's it. That was AKS in action. And if you have any question, feel free to send them in the Q&A window. I will be there to answer. I want to thank you very much for taking a part in this demo, and thanks.